Hello guys, in this tutorial I'm going to make this diagram. Yeah, you can see it's consist of a large capacitor filled with some dielectric, and then after it connected to a battery or cell, and then after in the second diagram it's also a capacitor but partially filled with dielectric and also a cell. So let's get started. We are gonna this like both diagrams. So yeah, all these three diagrams are from the previous like tutorials. So let's hide all this because we're gonna run code little slower. So just people just comment out whole thing and begin. Like firstly page break and then begin like center, and then begin next text picture inside the center. So firstly let's see, there is a cell and bars. So let's draw this diagram first with a large capacitor. So we are gonna draw like cell in the middle. So let's say minus 3 comma 0 2, then battery. Battery 1 will be better. So battery 1, let's put node is capital V. So level is equals to capital V, and then to 6 comma 0. 6 comma 0 is for symmetricity, you can just put anything. So cell will be in the middle, which is sorry, not 6 comma 0, 3 comma 0. So cell will be in the middle, which is 0 comma 0. So yeah, as you can see, it's a cell of potential V, and let's draw this capacitor, large capacitor. So yeah, you can use capacitor command for this also with dielectric, but I'm gonna do some basic drawing like rectangle and lines kind of thing. So firstly draw this wire, like this wire and this wire, and then we can just join in the right side as well. So draw, and we want to draw a line from minus 3 comma 0 to 2 will by default just join line. So here you can use relative coordinate or absolute coordinate, it doesn't matter. So we can just put minus 3 comma 2 or 3, let's say 3, and from here let's first draw this line, and again you can repeat for 3 comma 0. So this will make two lines, one for the left and one for the right. So yeah, as you can see, it's drawn two lines, and now it's time to draw this rectangle or capacitor. So we can do in a much simpler way. So let's continue this to further. This time we're gonna say minus 1 comma 3. So this will join minus 3 comma 3 to minus 1 comma 3, and we can continue for the right part as well. This time we want from 1 to 3. So yeah, and in the middle we want to draw this line and the rectangle filled. So for this what we can do, so one thing you can do is continue doing in the same command, or you can just draw a separate line and place it there. So let's firstly define this coordinate. So draw, we want to draw a line from here like 1 unit upward as well as 1 unit downward. So from this coordinate like 1 comma 3, sorry, minus 1 comma 3. So now here is the most important part. From this point we want 1 unit downward. So we can calculate from this. So let's wind this inside the dollar sign, because we're gonna calculate. So let's this is the first coordinate. So from this coordinate we want 1 unit downwards, so we can calculate the next coordinate. So plus, we're going to 0 comma minus 1. So this will just calculate a point somewhere like here, and we want to join a line to just copy this coordinate, and just we can put, and we can change from -1 to +1. So this coordinate will be like from here, and this coordinate is like to here. So if we run this code, we are gonna draw a line. So yeah, as you can see, it's drawn properly, and we can do the same for the right part. So command C, command B, and this time we're gonna just change -1 to +1, because we want like this coordinate to be like that. So yeah, as you can see, it's drawn properly, and now is the time to fill the area in between. So for filling the area, we can just draw a rectangle from like this coordinate. So let's copy, from this coordinate, and just say rectangle to this coordinate, like from here to like a rectangle draws from diagonally. So command C, command V, and if we run this code, we're gonna see, I think, nothing, just a bar. So yeah, as you can see, it's a rectangle bar is drawn, and now is the time to fill this rectangle with northeast line. So pattern is equals to northeast lines. So yeah, as you can see, for the filling, like you can just use solid color as well, but here we are going to use pattern. So to pattern, you can just define pattern. Pattern is a keyword argument, so pattern is equals to northeast lines, or you can say north south line, depending on how you want the lines. So as you can see, it's drawn properly, and you can just say fill here, because as you can see in this diagram, the upper line you can hide, so they just fill. So yeah, as you can see, upper lines are gone now, and we are just making this rectangle as fill only, not draw. So it's looking perfect, and you can just compress the width. You can see in the diagram, actually it's less wide. So for that, you're gonna do a whole lot of things to modify here, but for right now, I think it's perfect. So as you can see, it's a basic diagram using the text, but we are going to modify something so that we can manipulate in much simpler way. So for that, we can define some coordinates. So let's first define this coordinate and this coordinate. So for that, just we're gonna say coordinate, and we're gonna say A. So A is like -1, 3. So -1, 3, and let's define the coordinate symmetrical to A at the right side. So we're gonna call B. You will get like idea in a bit why we are doing like this. So these are the true coordinates A and B, and this is the magic thing gonna happen. So we want -1, 3 is to be A. So just we're gonna replace this whole coordinate A, and this coordinate to be B, and also to be B, and you can do similar thing for this A and B. And now one more thing we have to do, -1, 3 for the A, 1, 3 is to B, And now if we want if we run, firstly let's check it out. So as you can see, nothing changes, but if you want a little thicker, so just we have to change this coordinate and this coordinate, so it will just change coordinate A and B, and all the diagram will settle according to A and B. So this is the better way to draw diagram by defining coordinate. By this you can just change a single coordinate, and the whole program will change accordingly. So yeah, this is how you can make the perfect capacitive diagram. One more thing we have to do is put a node like for the D, this part like D. So for that, let's put a node. So for node, let's say draw, and we're gonna do like arrow kind of thing. So we're gonna put in the optional thing, and we're gonna draw from this coordinate to this coordinate. So two things you can do from here, either calculate coordinate or you can just put manually. So we're gonna calculate coordinate here. So this coordinate is A, so let's say A, and from A we're gonna move downward, so 0 comma minus 1.5 minus 1.25, let's say. So this coordinate will be about here, and we want a line from there to right. So we're gonna double dash and just put plus, that means it will render a relative line. So from there we want to move 1 unit, because the width is 1 unit. As you can see, it's goes from minus 0.5 to 0.5. That means we want to move 1 unit towards right, and in between we want to put node. So for node, and we can just say midway below, and in the node we want to say D. So as you can see, it's D, small d, and if we render all this, we want to see a like dimension kind of thing. Yeah, as you can see, it's a dimension. So yeah, this is how you can make a perfect capacitive circuit filled with dielectric. And in the second part, we are gonna make the same diagram, but like this. We can use 3 capacitor, or you can like whole thing in a repetitive way. So let's copy all these diagram, because both diagrams are exactly same with like smaller differences. So let's render it first. So as you can see, both diagrams are absolutely same, but for that we're gonna say minus 1 1. So as you can see, it's wider now, but we can change it. So we can define something different, like we can just define mid coordinate as well, and right side forward as well. So let's say we're going to define 2 more coordinates. So this time we're going to say A dash and B dash. A dash is like this is A, and this will be A dash, and B dash, this is B, this will be B dash. So we're gonna say minus 1, and B dash gonna say 1. So we drawn this capacitor which is filled like so. Just we have to change A dash and B dash. If we run this coordinate, yeah, as you can see, it's still thicker, so we can change, I think, 0.5 and positive 0.5. So yeah, as you can see, it's still D, but node we have to change, or you can say dimension we have to change. So for the dimension, as you can see, it's half of thickness divided 2. So just we have to say divide 2, or just you can shift this node so that we do not have to change anything. Just it will shift the whole dimension thing for the D, and we can define another dimension for the other 2 parts. So let's say A, and we want like divide 2, and one more time for the right side. This time we want from B dash, so B dash, and this also is divided by 2. So yeah, as you can see, it's perfectly drawn exactly like this diagram. But I think one confusion should be in your mind, that the width of this dielectric is exactly the width of like a vacuum capacitor, but we are like having divide 2 dimensions. So you can change all these like dimension a dash b dash like that. So let's say 1.25 1.25, this will like change a bit. So as you can see, it's drawn, but you have to change this dimension as well for, let's say, 0.75 0.75. So yeah, as you can see, it's perfect now. So yeah, this is how you can make diagrams. And one more thing I have to do, as you can see, lines are thinner, so we can put a node, set up a styling thing which is thick. So yeah, this drawn a like much thicker lines, and for the downward like diagram we can also set thick. So yeah, this is how you can set up the diagram. And one more thing we have to do, we have to place the this diagram side by side, not up and down. So for that, let's copy this whole diagram, and you can just put side by this. For that we can use a scope. A scope is a environment inside the text picture, and if we paste this code, so it will draw on top of this. Let's render it first. So as you can see, let's delete this diagram first, and now render it. So as you can see, both diagrams are on top of each other, but we can change this whole scope thing. So just we have to shift X. Shift is equals to 2 centimeter, or you can say like 5 centimeter. In reality we have to do 6 centimeter because the width of diagram is 6. So let's say 7 centimeter. 7 centimeter would be perfect, I think. So yeah, as you can see, the whole diagram is shifted side by side. So this is how you can use a scope environment. And yeah, that's it. This is how you can make the capacitor, or you can say capacitive circuit. So yeah, as you can see, it's perfectly done. Or I think we can do something more. You can change the color of pattern, or you can say color of dielectric. So here you can say, I think, pattern color, or let's say just color. Color is equals to red. I don't think color will work here. No, color won't work. So pattern color, I think. Yeah, pattern color is the keyword argument for this pattern thing, and you can do this in the second diagram as well. Yeah, pattern color is equals to red. Or if you want black or different color, it's totally fine. Like I think black looks perfect on red, on top of red, for the dielectric. So yeah, this is how you can make electrical circuit. So this was, I think, tutorial number 3 for the electrical circuit, and thank you. See you in the next one.